Advanced mapping techniques incorporating remote sensing and machine learning are transforming the way vegetation is mapped in Western Australia. These unique technologies are augmenting and extending field observations and can be used in the revision of carrying capacities of pastoral leases across Western Australia. The current method for estimating carrying capacity is based on land system mapping. Pasture types are not mapped but attributed to each land system on a regional average basis. As a result, the carrying capacity of land systems is a regional average rather than a specific estimate based on the distribution of pastures across a lease. While estimates of lease carrying capacity have been updated in some areas, many estimates are based on survey data that may be decades old and do not account for the impact of climate change on pasture productivity or changes in pasture distribution. Advances in remote sensing and computing technology allow rangeland vegetation groups to be mapped for the first time in Western Australia. Alongside this mapping, an extensive consultation process to reassess the carrying capacity of vegetation groups will allow us to make improved and updated estimates of lease-level carrying capacity. To predict the distribution of rangeland vegetation groups, new vegetation maps are made from field-collected data observations, multiple spatial data sets, and 20 years of satellite imagery. Now, instead of relying on historical averages and regional land system estimates, carrying capacities can be assigned by rangeland vegetation groups mapped across each station. Imagine a series of large maps of the rangelands in Western Australia. This spatial data has been captured by satellites and other methods. Each pixel has a unique signal that tells us something about the ground beneath it. For example, whether it's the reflectivity of the ground or vegetation, the chemical composition of the soil and bedrock, climate, elevation, or other environmental features. Field observations are used to train computer models to understand what the different combinations of spatial data represent. From this information, we can develop rules to assign pixels to a vegetation type. Machine learning models are being trained on nearly 70,000 geolocated pasture-type observations. These maps will be used to calculate the carrying capacity by matching each vegetation group with the updated estimates of grazing potential. Pasture types with similar ecology and pastoral potential are merged into broader groups known as rangeland vegetation groups and then modelled and mapped. Map accuracy is calculated relative to holdout sites from the field observation dataset, which are not flawless, as well as evaluated by regional department staff. The current approach contrasts with older methods which relied on land system descriptions and approximate pasture type allocations by land unit and were based on regional averages that did not account for on-station differences. While this mapping approach makes excellent use of over 50 years of historical field data, early field observations may have some geolocation inconsistencies due to older GPS technology, bushfires and other processes that may have altered vegetation since data collection. Data collected for specific high potential areas can also introduce spatial bias. Nevertheless, by combining decades of observations and environmental maps with rapidly developing data science, we can offer an alternative to traditional methods of estimating pasture-type distribution. While historical methods of estimating carrying capacity have been robust and valuable, remote sensing and machine learning now offer new mapping techniques. Embracing these new technologies combines the best available spatial data and local knowledge in a system that can be improved over time.